Good morning, class. Today it is finally time to go over your study guide for Chapter 3 in order to prepare for your Chapter 3 test. Yesterday you should have torn out and completed pages 183 all the way through page 188, front and back, 3 pages. If you have not completed those pages, then you need to stop this video and go finish those pages before you watch this lesson. Okay, let's begin. We are doing the Chapter 3 study guide from your GoMath textbook. Here we go. There are 3 boats on the lake. 6 people ride in each boat. Remember, each is a clue word for multiplication. How many people ride in the boats? Okay, now here's where this is very important. You need to make sure you read all of your directions and follow all of your directions. Your directions say, draw equal groups to model and explain how to solve it. So you're going to be doing 3 things here. You're going to draw equal groups, explain how to solve it, and write your answer. All right, so if I have 3 boats, let's draw 3 boats because that'll be drawing our equal groups. So let's do ovals. That's kind of like a boat. So here's my 3 boats, right? And then how many passengers are in each boat? Well, it says 6 people ride in each boat. So now I need to draw 6 people. So I'm just going to put circles for their heads. You need to draw 6 in each boat because remember, when we're talking multiplication, we're talking equal groups. Okay, so now I've drawn equal groups to model my problem, right? What would be my multiplication number sentence for this problem? If you have 3 groups of 6, how would you write that? Well, you would write that as 3, let's put it over here, 3 groups of, so 3 times 6. All right, we're still waiting to find out. Okay, so there's a couple different ways that you could solve this. You could skip count by 6s. You could do repeated addition, 6 plus 6 plus 6. You could sit here and just count all the people in here. So let's do 6 plus 6 plus 6, right? So 6 plus 6 plus 6. I know 6 plus 6 is 12. And then what's 6 more? 13, 14, 15, 16, 17, 18. So 3 times 6 is 18. So there's 18 people in all of the boats. But I also need to explain how I solved it, right? So what we did is we drew, so I drew 3 groups of 6. That's what we did, right? 3 groups of 6. Then I used repeated addition to solve. That's what we did. And now you are finished. So you're going to notice in your Chapter 3 GoMath series and from here on out in other grade levels that your questions may ask you to do multiple things. We needed to say how many people rode in the boats, which is 18 people. We needed to draw equal groups to model, which we did right here. And then we needed to explain how to solve it, which we did right here. So if you were taking this test in class, you would have a point for your equal groups, you would have a point for the correct answer, and then you would have a point for explaining how you solved it. So you have to make sure that you check every box. You do everything they're asking you to do. All right, let's keep going. Nadia has 4 sheets of stickers. There are 8 stickers on each sheet. She wrote this number sentence to represent the total number of stickers. 4 times 8 equals 32. So 4 groups of 8 equals 32. Okay. What is a related number sentence that also represents the total number of stickers she has? Okay. Now, we learned about this in a lesson. Okay. We learned about this, that a related multiplication sentence is also going to be the multiplication sentence that you can come up with using the commutative property of multiplication. Okay. But in case you don't remember that, let's say you don't remember how to do that, there are other ways that you could solve this problem. You could solve each of these. If they don't equal 32, then you know that they are not a related number sentence. So for example, 8 plus 4, what is 8 plus 4? It's 12. So that's not it. 4 plus 4 plus 4 plus 4 is 16. That's not it. 8 times 8, which you don't know that, but I'll tell you what it is. That's 8 groups of 8. So you know that that's way more than 4 groups of 8. That's double. So 32 doubled is 64. And then you have 8 groups of 4. Well, that is the reverse of 4 times 8. That is showing me the commutative property of multiplication, which tells me that the sum will be the same. Or the product, sorry. I don't know why I said sum. So this problem is your related number sentence. Remember, they're talking about the commutative property of multiplication. Lindsay went hiking for 2 days in Yellowstone National Park. The first jump on the number line shows how many birds she saw the first day. She saw the same number of birds each day. Okay, so let's look. How big is her first jump? 8. So that means she saw 8 birds the first day, 16 birds the second day. Okay. Write the multiplication sentence that is shown on the number line. Now, we talked about this until we were blue in the face on our lessons, that the order matters. The number sentence that you write right here, should represent this exact photo. So you should remember, with number lines, it's jumps of that represents your multiplication symbol. So how many jumps did she make? 2. 1, 2. So there's 2 jumps of, how big was each jump? 8. So your multiplication sentence should be 2 times 8. 2 jumps of 8. If you wrote 8 times 2, you are incorrect, because a number line for 8 times 2 is going to have 8 small jumps on it. Okay? Now, to find the answer, we need to find where we landed. Well, we landed on 16. So that tells me that 2 jumps of 8 totaled to 16, or 2 times 8 equals 16. All right, flip your paper over. Any mistakes that you may have made on your study guide, this is your opportunity to pause the video throughout this lesson and make corrections. You don't want to just say, oh, I didn't do that right. I want you to make the corrections so you can learn from it, okay? Number 4. Paco drew an array to show the number of desks in his classroom. Write a multiplication sentence for the array. Now remember, we are good mathematicians, so the first thing that we're going to do is label our array. So how many rows? 1, 2, 3. So I'm going to put a 3 over here. Okay, how many columns? 1, 2, 3, 4, 5, 6, 7. So I'm going to put a 7 up here. So I can see that this array has 3 rows of 7. And when we're writing a multiplication sentence for an array, the multiplication symbol is represented by the words rows of. So how many rows? 3 rows of 7. If you write 7 times 3, you are incorrect, because that array is going to look much different. Now, to find your answer for this, you could skip count by threes all the way down. You could use repeated addition of 7 plus 7 plus 7, or you could sit and count up all these boxes, okay? Let's skip count by threes. So 3, 6, 9, 12, 15, 18, 21. If I wanted to check it, I could say 7 plus 7 is 14, plus 7 is 21. Okay? All right. Alondra makes 4 necklaces. She uses 5 beads on each necklace. For numbers 5a through 5d, choose yes or no to tell if the number sentence could be used to find the number of beads Alondra uses. Okay, well, first of all, if she has 4 necklaces of 5 beads, then that means she has 4 groups of 5, also written as 4 times 5, right? Okay. All right. So let's see. Here we go. 4 times 5. Well, boom. I already know right there that is a way she could solve it. Okay. Now you look at your repeated addition. 4 groups of 5. 4 plus 4 plus 4 plus 4. Well, that's 4 groups of 4, not 4 groups of 5. If I was to write this multiplication sentence out in repeated addition, I would need 4 sets of 5. 4 sets of 5, or 4 groups of 5. So that means I would add 5 4 times, because I have 4 groups of 5. So this group has 5, this group has 5, this group has 5, and this group has 5. So you could also say it as I've written 5 4 times. So 5 plus 5 plus 5 plus 5 is the same. Yes, I could use that to solve this problem. 5 plus 4. Absolutely not. There's nothing equal group about that, or repeat addition or anything. All right. John sold 3 baskets of apples at the market. Each basket contained 9 apples. How many apples did John sell? Make a bar model to solve the problem. So down here I have the blue box and then apples. That's showing me that I don't know how many total apples. So this represents the total amount of apples, right? So how many baskets did John sell? Okay, well, he sold 3. So I need to make sure my bar is in 3 groups. So there's my 2 lines. So now I have 1, 2, 3 equal groups. Okay, each one of these groups represents a basket. Now, how many apples were in each basket? There were 9. And with a bar model, we don't have to draw a picture. We're just going to write 9 in this basket, 9 in this basket, and 9 in this basket. Okay? Now, there's different ways you could solve this. You could skip count by 9. Some might say that's too difficult. You could use repeated addition. So I could say 9 plus 9 is, I'll do it this way for you. 9 plus 9 equals 18, plus 9. 8 plus 9 is 17. 2. So I know that it totals 27 apples. Let's take it a step further. Who could tell me, how would I write this in a multiplication sentence? Remember, we drew 3 groups. So remember the term groups of. When you use the term groups of, you have 3 groups of 9 that total 27. Okay. Grab your next page, page 185. Here we go. Select the number sentences that show the commutative property of addition. Mark all that apply. Every time you see mark all that apply, that means there could be more than one answer. So first, let's remind ourselves, what does this property say? If you don't remember, this is the time when you grab your vocabulary cards from the beginning of the chapter and read over it to refresh your memory. The commutative property of multiplication says that the order of the factors does not matter because the product will remain the same. Okay? So that means the order of the factors can change and the product will not change. So 3 times 2 equals 2 times 3. Did the order of the factors change? Yes. Just the order, not what factors we're using. Just the order of factors changed. Okay, look at the next one. 4 times 9 equals 4 times 9. Yeah, they're equivalent. They equal the same amount, but are they demonstrating the commutative property of addition? No, they're not. To demonstrate it, they would show that the order doesn't matter. 5 times 0 equals 0. Nope, that's showing us which property? Hopefully you said it. That's the 0 property of multiplication. Any number times 0 equals 0. Good. 6 times 1 equals 1 times 6. Is that showing that the order changed with the same factors? Yes, it is. All right, and last, 7 times 2 equals 14 times 1. Are those equivalent? Yes, they are. 7 times 2 equals 14. 14 times 1 equals 14. So this equation is true. However, this equation does not show us the commutative property of addition, of multiplication. Okay? These are completely different factors. Number 8. A waiter carried 6 baskets with 5 dinner rolls in each basket. How many dinner rolls did he carry? Show your work. Show your work. When it says show your work, you better be ready to draw a picture, draw a number line, draw a bar, whatever you got to do, show your work. Okay? Do not just boom, write an answer. So I have 6 baskets of 5 dinner rolls. Let's draw a picture. So here's 1, 2, 3, 4, 5, 6. I have 6 baskets. My drawings aren't perfect, but this is math and that's okay. And then inside each basket should be 5 dinner rolls. So let's draw those. Whoops. I probably should have drawn my baskets a little bit larger. All right, now I have 6 baskets, 5 dinner rolls in each. So if I was going to write this as a multiplication sentence, what would I write? 6 groups of 5. Good. Now, I need to figure out how I'm going to solve this. How am I going to solve this? I could use repeated addition, 5 plus 5 plus 5 plus 5 plus 5 plus 5, or I could skip count by 5s. Skip counting by 5s is fairly simple. Let's do it. 5, 10, 15, 20, 25, 30. So I know my answer is 30 dinner rolls. By simply drawing a picture and writing the number sentence, I have shown my work. Anytime it asks you to show your work, make sure you do so. A good mathematician will always show their work, though. Sonia needs 3 equal lengths of wire to make 3 bracelets. Sorry. The jump on the number line shows the length of one wire in inches. How many inches of wire will Sonia need? Sorry. Will Sonia need to make the 3 bracelets? Okay. So her jump is the length of one wire. All right. So I have 3 bracelets or 3 groups of 3, correct? So that means I have 3 jumps of 3. That is not true. You need to read this next line. Sometimes you want to jump through and circle those numbers and then boom, that's it. No. 3 equal lengths of wire to make 3 bracelets. That's it. The wire is the bracelets. Okay? So 3 groups is all you have. What you need to know is the length of each wire. So the length of each wire is the size of each jump. So look at her first jump. She lands on 6. I'm going to draw her lily pad since these don't have lily pads. Her first jump lands on 6. So that means each wire is 6 inches long. So that means 3 bracelets with each wire being 6 inches long. Correct? Yes. So now we need to solve this to figure out how many inches of wire she'll need. So that means I'm going to have 3 jumps of 6. So let's draw our next lily pad so we can jump. 1, 2, 3, 4, 5, 6. Draw it. Keep going. 1, 2, 3, 4, 5, 6. Now I can draw my jumps. So I've got 1 jump, 2, and 3 jumps of 6. Where did I land? 18. So she needs 18 inches of wire. Do you see how easy it is to look at 3 and 3 and write 3 times 3? You've got to read carefully. It says the jump on the number line shows the length of 1 wire. And when you check this jump, you see it lands on 6. Okay, so always read your problems very carefully. Number 10, Josh has 4 dogs. Each dog gets 2 dog biscuits every day. How many biscuits will Josh need for all his dogs for Saturday and Sunday? Okay, well, first of all, let's do Saturday. So for Saturday, he has 4 dogs, and they each get 2 biscuits. 4 times 2. Okay? If you wanted to make that more simple, you could do 1, 2, 3, 4, and put 2 in each group. Now, that's not it. That's not the end of it. It says Saturday and Sunday. And is a clue word for addition. So on Sunday, he still has 4 dogs that each get 2 treats. So again, I'm drawing 1, 2, 3, 4, and 2 treats each. Now I need to find the total for Saturday and Sunday. Because I have 2 in each, I can easily skip count by 2. So 2, 4, 6, 8. So I know that's 8. And that means that's 8. Now let's keep going across to get the total amount. 2, 4, 6, 8, 10, 12, 14, 16. You also could have got the total for Saturday, which is 8, and added it to the total for Sunday, which is 8, to get 16 biscuits. All right, turn your paper over. Okay. Jorge displayed 28 cans of paint on a shelf in his store. Select other ways George could arrange the same number of cans. Mark all that apply. So this is an array. And first thing we need to do is label it and find the total, right? So let's label it. I've got 4 rows of 1, 2, 3, 4, 5, 6, 7. And we know it totals 28, right? So 4 rows of 7 equals 28. Okay, so I need to find out which ones of these will also equal 28. Now this is going to take some working out on the side because you don't have your facts memorized, but that's fine. 2 rows of 14, okay? So then if I have 2 rows of 14, then that's 14 plus 14, and that totals 28. So does that total the same amount as 4 rows of 7? Absolutely. If it's hard for you to figure this out with pen and paper, then you could grab whatever counters you've been using to make arrays, count out 28 of them, and then see if you're able to make these using just your 28 counters. All right, let's keep going. One row of 28. Wait, we know this one. One row of 28. 1 times any number equals that number. So that totals 28. So could we make that array with 28 cans? Absolutely. Six rows of 5 would be 6 times 5. Okay, so 6 groups of 5. So we could skip count by 5, right? And how many times will we need to skip count by 5? Well, it's the same as saying 6 groups of 5 or 6 sets of 5. So it would be 1, 2, 3, 4, 5, 6. You would need to skip count by 5 6 times. So 5, 10, 15, 20, 25, 30. Now, can we make this array? We cannot because we only have 28 cans. Let's try 8 rows of 3. Okay, 8 rows of 3. All right, so that would be the same as we did before. We could skip count by 3 8 times. Okay, so that would be 1, 2, 3, 4, 5, 6, 7, 8, which would be 3, 6, 9, 12, 15, 18, 21, 24. So 8 rows of 3 equals 24. So can we arrange the same number of cans? We cannot, because 28, it doesn't equal 28, it equals 24. What about 7 rows of 4? 7 rows of 4. So that would be 7 sets of 4. So 4 plus 2, 3, 4, 5, 6, 7. All right, we can skip count by 2's twice, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So that means that 7 rows of 4, or 7 times 4 equals 28. Can we make this array? Absolutely, yes we can. Hopefully you also noticed when I wrote down this multiplication problem, 7 times 4, that is a related multiplication fact to this array, 4 times 7. Number 12, choose the number that makes this statement true. The product, remember the product is the answer to a multiplication problem. The product of any number and blank is 0. Well, how do I get 0 with the multiplication problem? Any number times 0 equals 0. All right, number 13. James made this array to show 3 times 5 equals 15. Let's check his work. 3, 1, 2, 3, 4, 5. Yep, 3 rows of 5. Okay, good job, James. James says that 5 times 3 equals 15. Is James correct? Draw an array to explain your answer. So let's draw an array of 5 times 3. So 5 rows of 3. So 1, 2, 3, 4, 5. And I want 3 in each row. 2, 3, 2, 3, all the way down. So now I have drawn an array for 5 rows of 3. Okay. Let's skip count by 5 to make sure that this still equals 15. 5, 10, 15. It does. So, yes, James is correct. Now, what number property supports this answer? That 5 times, oops, sorry, I didn't mean to write on my paper. 5 times 3 also equals 15. Okay, well, all we did was change the order of the factors, correct? And the property that states and discusses changing the order of the factors does not change the answer is called what? Well, let's think about it. Let me think about it. Let's think about it. the commutative property of multiplication. If you didn't know how to spell it, you should have either A, looked at previous questions, or pulled out your vocabulary cards to find out how to spell it. All right, kids, grab page 187. These are our last pages. Here we go. Julio has a collection of coins. He puts the coins in 2 equal groups. There are 6 coins in each group. How many coins does Julio have? Use the number line to show your work. So the first thing I'm going to do is I'm going to write a number sentence using the information from the problem to help me figure out how to do my number line. So if I have 2 equal groups, 6 in each group, that means I have 2 groups of 6. 2 groups of 6 is written like that, right? Now if I'm doing a number line, I know that we translate this multiplication symbol by saying 2 jumps of 6. So now that I've written it out like this, I can say clearly that I need to make 2 jumps that are each 6 long. So let's draw our lily pads. 1 on 0. Our first jump will go to 6, and then we need to count 6 more. 1, 2, 3, 4, 5, 6. And let's draw jump 1 and jump 2. And we land on 12. So my number line shows me 2 jumps of 6. If you jumped 6 times and they were each too long, then your number line is not correct. So you may have gotten the correct answer, but you would get your number line marked wrong. Your number line is a picture representation of your multiplication problem, and it should represent that exact problem. So 2 times 6 is 2 jumps of 6. So I got 2 jumps, 6 long. All right, Landon collects trading cards. Part A. Yesterday, Landon sorted his trading cards into 4 groups. Each group had 7 cards. Draw a bar model to show Landon's cards. How many cards does he have? So we're going to draw a bar model. So that means we need a bar. There's our bar. And our bar needs to have 4 groups. So I've got 1, 2, 3, 4 groups. And each group needs to have 7 cards. So you get 7, and you get 7, and you get 7, and you get 7. And we need to find out this total amount, right? So let's try some repeated addition, shall we? 7 plus 7. Okay, well, I know that 7 plus 7 is 14. So technically, this would be like if I said 14 plus 14, right? And let me do that down here, because I'm a good mathematician. Oops, I almost wrote the answer. And I show my work. 4 plus 4 is 8. 1 plus 1 is 2. So 7 plus 7 plus 7 plus 7 is 28. Boom. Now, Landon buys 3 more packs of trading cards today. Each pack has 8 cards. Write a multiplication sentence to show how many cards Landon buys today. Then find how many cards Landon has now. Show your work. So much to do. So yesterday he had 28 trading cards. Today he got 3 packs of 8. We need to find out how much that is. That's question 1, right? And it tells me, it wants me to write a multiplication sentence. But I don't have my facts memorized. So let's draw a picture. So if I have 3 packs of trading cards, 1, 2, 3. And each pack has 8 cards. 8, 8, 8. How many is that in all? Well, we can add them up, right? 8 plus 8 equals 16. Good. And 16 plus another 8 equals 24. Good. Okay. I'm not done, though. I need to write a multiplication sentence. If I have 3 packs of 8, that means I have 3 groups of 8. I'm writing it on the line because that was part of my directions. Write a multiplication sentence. 3 groups of 8 equals 24. 24 what? It says how many cards? So 24 cards. Okay? Now I'm going to draw a semicolon to break apart because I need to do a separate problem. Because it says, then find how many cards Landon has now. So to find how many cards Landon has now, I need to take the amount he had yesterday, which is 28, and add that to the amount he got today, which is 24. Okay, so I need to add 28 plus 24. It says show your work, and that's exactly what I'm doing. When you are doing your study guide, you should have all this writing all over yours too, because you need to show your work. All right, so when I added yesterday's cards with today's cards, I got 52. So Landon has 52 cards now. All right. Number 16. A unicycle has only one wheel. Write a multiplication sentence to show how many wheels there are on 9 unicycles. Okay, so let's think about that. What's our group? Our group would be the unicycle, right? So I have 9 bicycles or 9 groups. So I have 9 groups, and each bicycle has how many wheels? 1, 9 groups of 1. And I know that the identity property of multiplication tells me that any number times 1 equals that number. So 9 times 1 equals 9. Carlos spent 5 minutes working on each of 8 math problems. All right, so he spent 5 minutes working on each of 8 math problems. He can use 8 times 5 to find the total amount of time he spent on the problems. For numbers 17a through 17d, choose yes or no to show which are equal to 8 times 5. All right, so if I have 8 times 5, that means that I can skip count by 5 8 times, right? Because it would be like 1, 2, 3, 4, 5, 6, 7, 8. And then I would skip count 5, 10, 15, 20, 25, 30, 35, 40. I know this equals 40. I know this equals 40. So, could I use 8 plus 5 to find this answer? No. What about 5 plus 5 plus 5 plus 5 plus 5? That's 1, 2, 3, 4, 5. This would equal 5 sets of 5, or 5 groups of 5. That's not what we're solving. What about 8 plus 8 plus 8 plus 8 plus 8? 1, 2, 3, 4, 5. This would represent 5 groups of 8. Okay, well, that's not the problem we're solving, but does that demonstrate the commutative property which states that the product will remain the same? 8 times 5, 5 times 8, yes it does. Now, then we have 5 plus 5 plus 5 plus 5 plus 5 all the way down. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 sets of 5. And that's exactly what my problem is. All right, flip it over. Last page. Lucy and her mother made tacos. They put 2 tacos on each of 7 plates. Select the number sentences that show all the tacos Lucy and her mother made. Mark all that apply. All right, first of all, let's figure out how many they made, right? So how many plates does she have? So that's your groups, okay? So I have 7 plates. How many tacos on each plate? 2. How much is that? Well, wouldn't that be the same as saying 1, 2, 3, 4, 5, 6, 7. 7 sets of 2. So 2, 4, 6, 8, 10, 12, 14. So 14. Same thing. All right, is that what they did here? 1, 2, 3, 4, 5, 6, 7. Yes, so that one works. What about 2 plus 7 equals 9? No, we're not adding. No. 7 plus 7 equals 14. No. 8 plus 6 equals 14. No. 2 times 7 equals 14. Yes. Now, hold that thought. Let's get our brain moving. How would you write 2 times 7 as a repeated addition? Well, that would be 2 sets of 7, so 7 plus 7. Wait a minute, didn't we have a problem that looked like that? Look. Go back to this problem. 7 plus 7 equals 14. That does work. This is why you don't ever want to rush through your work, okay? Because they put this addition problem here and this addition problem here to trick you, okay? Once you got down here, you should have realized, oh, wait a minute. 7 plus 7 represents 2 times 7. Okay, let's keep going. Jason is making 5 sock puppets. He glues 2 buttons on each puppet for its eyes. He glues 1 pom-pom on each puppet for its nose. Write the total number of buttons and pom-poms he uses. Okay, so the first thing that you need to do is draw a picture. That's the easiest way to do that. So let's draw 5 sock puppets. I'm just going to draw them like this. I don't really know what they look like. And then I need 2 buttons for eyes. Button, 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 button. And 1 pom-pom for the nose. So let's do a big circle so we know the difference. These kind of look like little ghosts, don't they? Okay, so my big circles are pom-poms. My little circles are buttons. So here we go. Write the total number of buttons and pom-poms he uses. Write a multiplication sentence for each. So for buttons, I have 1, 2, 3, 4, 5 groups of. How many buttons in each group? 2. Let's skip count. 2, 4, 6, 8, 10, which totals 10 buttons. Now let's do noses. Again, I have 5 groups. How many noses on each? 1, 2, 3, 4, 5, totaling 5. So I have 5 pom-poms. All right, you with me so far? Okay. After making the 5 puppets, Jason has 4 buttons and 3 pom-poms left. What is the greatest number of puppets he can make with those items if he wants all of his puppets to look the same? Draw models and use them to explain. Okay, so he's got 4 buttons and 3 pom-poms. So 3 pom-poms would make 3 puppets, right? 1, 2, 3. Okay, so pom-pom, pom-pom, pom-pom. There's my 3 noses. But can they all be the same using just 4 buttons? I need 2 buttons for each nose. So when I do that, I don't have eyes. I don't have buttons for the eyes on the 3rd one, so I can't make him. So this shows me that at most he can make 2 more puppets. That's it. Because he said he wanted them to all look the same. So 2 more puppets. That's it. Okay, so we drew models, and how are we going to explain that? Well, we know he can make 3 puppets with 3 pom-poms, but only 2 can have eyes. with his 4 buttons. All right. I hope you have a better understanding of your study guide now, and I really truly hope that you took the time to pause the video and make corrections on your study guide and did not just sit here and listen and write down answers. Have a great day.